Hello, welcome to the next webinar in our series. My name is Tom Danvers from Waygate Technologies. We're going to be taking you through, for the next 30, maybe 40 minutes or so, the latest content on our new Borescope, the Everest Mentor Visual IQ Plus. Don't forget the plus, specifically the latest Real3D measurements on that device. But first, before I really dig into the content, we really want to show you just an introductory video introducing the new device that we've launched approximately 1 month ago. So just sit back and enjoy this video. It's about 2 minutes long. Thank you.
The demand of inspections is daunting because you're not just facing the challenge of the task at hand, you're facing the elements that are never on your side. Every second counts. Every decision can put lives on the line, and so many people are relying on you to get it right. You need a mentor, one that helps you optimize, digitize, and ultimately meet the demands you face. You need the Everest Mentor Visual IQ Plus from Waygate Technologies. This next-generation video borescope features a revamped steering engine for more degrees of articulation and leverages the power of AI to be your second set of eyes, identifying and classifying defects in real time. Plus, with Real3D and its interactive 3D point cloud, you'll avoid errors and get confident results from each inspector every time. And if you're capturing a lot of data, you'll find plenty of room for it here. The Mentor Visual IQ Plus boasts 5 times as much internal memory as the previous model and provides continuous data backup to the cloud. Now you can spend less time managing your data and more time focused on your inspections. Time is never on your side, but now it can be, thanks to increased processing power for faster measurement, stitching, and analytics on edge, like ADR and blade counter. And you can experience it all at 60 frames per second through our best-in-class live HD video feed.
Hey Mentor, blade tip clearance measurement. Save image.
Oh, and voice recognition? It does that too.
So I hope you like the video. Yes, very excited to present to you the new Everest Mentor Visual IQ Plus. This webinar specifically focusing on the measurement, the new updated measurement content that we have accommodated in this new device. So specifically, there's lots there, new content, new technologies and new content accommodated in the new Borescope, but this is specifically focusing on the measurement side. So we'll be taking you through the new measurements and also a new feature that we've accommodated into the device called Learn More. So I'll take you through, if you haven't already connected or viewed my webinars late last year, I focused a lot on measurement last year and specifically talking about Real3D. So I'll give you a brief recap on what actually Real3D measurement is. Take you through those new measurement types and an overview of Learn More before moving on to a sort of a practical demonstration of it using my Borescope on here that you see over my shoulder. And because this is a new Borescope, we have remodified the equipment or the model listing. And so we can kind of briefly take you through the different models and what's included in each of the models, certainly from a measurement point of view. Hopefully I'll remind myself throughout this session to make sure that you ask questions. I do enjoy receiving questions and responding to them at the end of the session. So if you have any questions, type them into the chat. I'll look at them and we'll respond to those hopefully at the end of this session. Okay, let's begin. So this is a slide that you would have seen hopefully from last year, just a recap on what all those measurement technologies that we currently have on our device. I'm not going to take you through all that. Obviously, there's a lot of information here, so you're welcome to pause on this and view this back. And there's a lot of information on our websites as well about this. But briefly, we have 4 different measurements on our Borescope, on the MViQ Plus Borescope. We have comparison, stereo, 3D stereo, and 3D phase. depending on what model you have, and indeed what tips you're using on your device will depend on what type of measurement you have available to you. For the purpose of this session, we'll be focusing on Real3D measurements and the new measurements included within Real3D. So you see here highlighted angle, surface angle, and missing corner. So that brings the total from 9 up to now 12 different measurement types for Real3D. So yes, Real3D capture is inclusive of 3D stereo as well as 3D phase measurement. So if you have a stereo tip fitted or a 3D phase measurement tip fitted, all of these measurement types that you see under Real3D are available to you, provided you have the right model and the software activated in that model. And we'll discuss that more in the future. So starting off, angle. Angle was actually a measurement that was previously part of the multi-segment measurement type. When a multi-segment being, as a reminder, the ability to place down multiple cursors and determine the length of the surface emergent length of all of the cursors that you place down onto the target. And angle was part of multi-segment if you place down 3 cursors. And we found that a lot of our customers didn't realize that feature was part of multi-segment. So we've lifted it away from multi-segment and given it a dedicated new tile for angle. So angle allows you to measure the angle between 3 cursor points. So basically you lay down the first, the second, and the third, and an angle is drawn between those 2 lines placed onto the surface. Angle is really designed so that you can determine the angle of a surface on a flat plane or near to flat plane. If you've got a curved plane or a deflected plane, then we'll talk about the more appropriate measurement to use here. But angle is really designed for use on flat surfaces. I'll take you through an example of why angle is applicable from an aviation or gas turbine inspection use case, specifically within the combustion chamber, measuring the angle of erosion, with it, for instance, in a dilution chute hole. Yes, and from a tips and best practices point of view, I always say this, I've not said it on the slide here, but always check your point cloud. When placing cursors onto the screen, don't just rely on the appearance of the cursors and the position of the cursors in the flat 2D image. Check your point cloud, interrogate your point cloud. And as I say here, make sure, because we're talking about an angle, the length of the lines is important, such that if they're too short, then the position of those cursors is even more critical and more sensitive to change in angle. So if you're measuring the angle on a flat plane surface, make sure that you're drawing those and projecting those lines out as far as possible so that you can fine tune the position of those lines so that you get a more accurate angle. Yes, and check the point cloud. So it's a very powerful way of making sure that you have got a good quality measurement placed onto the screen. As a bit of a little bit of a teaser, you see on the screen on the image here, angle shown on the image that you see. This is a picture from our Learn More page, so you can learn more about all of the measurement types by entering this space, and I'll tell you more about that shortly. So angle, not technically a new measurement. It was part of multi-segment, but it is now a dedicated new tile on the measurement page. This, however, is a brand new angle, a brand new measurement type called surface angle. Just like angle before, outputs the measurement in degrees. The difference here is laying down a reference plane. So you lay down your first 3 points on cursors onto the point, onto the target. And as you can see, it's when you lay down 3 points, just as you would do if you're determining a depth measurement, you're creating a reference plane, and the 3D surface mask that you see flooded in green on this image tells you the relative agreement of all of those surfaces in addition to those 3 points that you've laid down, plus or minus 1%. So you lay down a really good quality reference plane where there's good agreement with your 3D surface mask, and the fourth point is placed onto the deflected surface. And as you can see on this snapshot, and I'll demonstrate it on the borescope shortly, then it presents you basically with two angles that obviously sum up to 180 degrees. And from that, and interpreting, obviously making sure that you're placing your cursor, your fourth cursor point correctly. The fourth cursor actually is not a point, it's a collection of pixels upon which a plane is generated. So the plane from your fourth cursor intersecting your reference plane is what determines the angle measurement. And you can use this in conjunction with measurement plane as well if there's noise or lots of bumps and deflections onto your target. So here's a great example where, from an aviation or gas turbine inspection point of view, we've got tip curl as a result of damage passing through the engine. Could be foreign or domestic object damage, and for whatever reason, it's causing obviously lots of damage as you go through the engine. And some blades sustain missing material, some blades sustain deflected material. So here's a deflected surface here. Other causes of deflection, for instance, could be ice impact damage or bird strike ingestion, bird ingestion that also causes deflection. So there are sometimes limits in the maintenance manuals that call out you determining the degrees or the angle of deflection. So surface angle is ideal for tip curl deflections. The third measurement type that's new on our MViQ Plus is missing corner. So similar to what you've heard me talk about from angle, missing corner was possible, but we found from the old method of laying down a measurement plane and using area. But we found there were instances where our customers weren't necessarily aware of that ability to do area measurements in conjunction with measurement plane. So we've lifted that section out and given it a dedicated tile on the measurement page called missing corner. And when you press the missing corner button, if you haven't already placed down a measurement plane, it will provide you with a notification or a message on the screen to say missing corner needs first a measurement plane applied. So there's some instructional guidance on the borescope to point you towards creating a measurement plane on the surface before then going back in and pressing the missing corner tile and laying down the points, in this case, to determine the various dimensions associated with missing material on the corner of this blade. The measurement output is a range of lengths, areas, and an angle. So obviously I'll talk to you more about that shortly. So yes, I'll take you through all that. And then, yeah, from a measurement cursor limit point of view, that limit of number of cursors is currently 24, as it was before. So you lay down all your cursors, provided they don't exceed that value. You can determine a very detailed shape that conforms to the irregularities that you get when you get this phenomenon happening on the edges of blades. And another new feature on our borescope is, as you've heard me say, is learn more. We are very aware of the capabilities. It's a very capable device, and what with capability is linked with complexity. So we're trying to bring more information, bite-sized pieces of information to you without you forcing to go to a manual or a website to learn more, or even necessarily read our measurement handbook, which is a fantastic resource, by the way. Learn more is on the device, so there's no network connectivity required, and provides you with more information, a short sort of paragraph or two of text that may be on 1 page or 2 pages. I'll take you more through it, of each measurement type. So for each of the 12 measurement types, for instance, that we have now on our new borescope, MViQ Plus, but also from the image transform page, we're offering you with much more information about all of the different image transforms, such as dark boost, invert, inverse plus, rotate, and even the simple ones like illumination on and off. So every single tile that we have in the image transform page, there is also associated information in the learn more there for image transforms and also measurement types. Not just 3D phase measurement types, but also stereo, 3D stereo, and comparison, as you heard me briefly say at the top of this this chart previously, where all the different measurement types, we've got learn more content for each of those 4 different measurement types. So with that, by the way, please do think of any questions and put them into the chat if you've got any. I'll switch my screens and show my Borescope. Let's just press a few buttons. Okay. So switching over to my Borescope, I've loaded some example images on my Borescope, and I'll take you through the workflow, how these measurement types are created on the Borescope. And I've also got a blade on my desk, so we can kind of do it live as well. So I'll just press my angle. So it's my first sort of simple image, just to show you the simple workflow to create a basic angle measurement. So I've loaded an image. Obviously, you can see here it's like an image of a protractor or various prescribed angles on a plate. Press the measurement button, and I'll just scroll down using my joystick so you can see the tile there. You've got all of the measurement types on that screen, and just as a reminder, we've got the I button that you can see on the top right. So that's where we're going to access learn more when I take you through that part. So, but first I'll take you through the angle workflow. So once you press the angle, you're invited to basically place down, let's drop it down here, put my origin around here, and put my third cursor here. So I've laid down 3 cursors, roughly place them down, and then I sort of tap and activate the cursor, and then I tend to sort of use the joystick or fine tune using the magnifying glass in the top right hand side. Very easy. Easy to add some more if I wanted to. And then you can, well, just like you can with other measurement types, there's up to 5 that you can place on any given image. And as you'd expect with this being a real 3D measurement, you've got the options to go to split view, which I spend a lot of time in this view. I quite enjoy having 2D on the, oh, I didn't need to do that. Let's just bring that back down. So I tend to sort of zoom in on my 2D view, for instance, whilst also, if I want to, zoom in on my 3D point cloud view on the right-hand side. And every time you're moving the cursors, you obviously, as you'd expect, the measurements are being updated. Or you can go to full point cloud view and interrogate the image in full point cloud view. If you go to full, then you've got all of the measurements now on shot. So that's a brief overview. Just simply lay down your cursors, your 3 cursors, and you've got an angle measurement created. Let's go to image number 2. Let's go back in, image number 2. So here's an image of this is an igniter plug within a combustion chamber. I think this is from a CFM56. Obviously, you can see no thermal distress. It looks like a brand new combustion chamber with being very white thermal barrier coating. But what I'm going to do here, I've seen numerous excerpts in maintenance manuals where it calls upon the requirement to measure the erosion around some of these holes, igniter plug holes and dilution chute holes. So here is an example where I'm going to lay down 3 cursors, but you'll appreciate if there's a requirement here to use measurement plane as well. I'll describe what I mean by just demonstrating here. So I'm not going to lay down a measurement plane. I'm going to intentionally lay down an angle. And if I just showed the 2D view, and you can kind of see, oh, it's producing an angle, and let's just say this is my extent of my erosion. But then you can see, well, 28 degrees doesn't look right. So as you keep hearing me say, always check your point cloud. So what's happening here is that third cursor is not placed in the center of the hole, it's actually placed in the background. And so that 28 degrees is a very, well, it is 28 degrees if I don't lay down a measurement plane that covers the hole. So I'm going to lay down a measurement plane. Let's switch views again. Quite like this one. So as soon as I lay down a measurement plane, it's going to lift that central cursor up to the measurement plane in agreement with the other two outer cursors. And you can see immediately the effect that it's had on the calculated angle from 29 degrees to 58 degrees. And again, if I activate that measurement type and interrogate the point cloud, you can now see my second cursor is aligned to the other two cursors. And provided that's adjusted to approximately the center of the hole, then you're going to get more accurate angle interpretations from that measurement. So there's an example of using angle in conjunction with measurement plane. Please, please, please always check your point cloud, and it will become much more clearer to make sure that you've assigned the cursors to the correct position. Okay. If I just press that, there we go. So this is my third recalled image. So this is obviously an example of looking at a damaged blade within, in this case, a compressor stage. Could be the HP4, I think, maybe, or 3. So you could probably determine that this is a deflected surface. I'm just picking out this. There's another image I've got next, which is a more deflected surface. But for this one, I'm just going to show you, go down to, in this case, surface angle, and take you through the use case or the workflow for surface angle. So you heard me say, first thing you need to do is lay down a reference plane. So that's 3 points. Check the 3D surface mask. That's the green filled in area. That looks, so basically that's going to tell me what's in agreement with those 3 cursors. So have I got a good reference plane? Is the quality of that image low in noise? If it was high in noise, then there would be lots of isolated islands of green surface mask. So in here, in this case, you've got a good agreement because there's a good flooded plane of green. And my 4th point, I've just tapped the screen, so generate the 4th point, place on the deflected surface. So you've got the 2 angles that add up to 180 degrees. Again, if you're not already on the split view or the point cloud view, do so straight away and check the point cloud, because this is the point where you need to just check the quality of your cursors and obviously checking the quality of your point cloud. So you can see quite easily there's basically 2 angle measurements, one corresponding to the pink or magenta, and the other one is the more purple. And you can see the 2 sort of angle symbols. And so you've got those 2 corresponding measurements for each of those, should we say, 2 angles that add up to 180 degrees. So just like angle, surface angle also generates just the output in degrees. Now, let's go to this next image. Do the same thing. Again, this is a saved or recalled image. I'm going to tap measurement, tap surface angle. There's my reference plane, and then tap for the 4th time to place the 4th cursor. Unlike, and I'll just bring you, so as you can see, when you've got an active cursor, it goes from a small circle to a very big circle. And you can see my 4th point is actually a circle, a much larger circle, whether it's active or inactive. The way surface angle operates is the plane of the surface generated within that 4th cursor, and how that interacts, how that intersects with the reference plane is what's being calculated. So clearly you do need to make sure that you're positioning that 4th point appropriately. And as I'm not in point cloud, I'm obviously just going through eyeballing it on the 2D image. So again, switch to one of the point cloud views, either the split or the full point cloud view, and interrogate it in this dimension. So by simply, if I minimize those buttons, you're able to just check the position. Is it relatively, is it saying something sensible? It does look like it's near to 90 degrees and it's coming out at 80 degrees, obviously on one angle and 100 on the other. And if you wanted to, you could adjust it again. So as a reminder, that fourth point is not just a point, it's actually a cursor that collects hundreds of pixels. And I don't think I know actually the number of pixels that actually contained within that cursor depends on its position and how its relative position to the edge of the blade. So it's not like a fixed number of pixels. So you can see the size of the circle changes, and as it approaches the edge of the blade, the size of the circle reduces, because what we don't want to do is include point cloud, include pixels and contribute to a plane that affects the angle. So it's dynamically adjusting the size of that area to generate the angle, to help generate that angle measurement. So, but it is many hundreds of pixels contained in that fourth cursor, and how that interacts and how that plane interacts with the reference plane is how the angle is created. So at this point, I was actually going to do that live on my Borescope. So I've got a blade on my desk. This is an edge of a blade, and it's been artificially deflected in a vise. And we kind of just wrenched over it and deflected the corner of the blade. And I positioned the Borescope, as you can see here, just sort of pointing down on it. Just going to take you through the use case associated with measurement plane and surface angle. So if I generate a point cloud and walk through the surface angle measurement workflow, so press measurement, press surface angle, lay down my reference plane, look for good agreement, and drop my fourth point on the deflected surface. So I've got split point cloud view already active, so I don't need to change the view. So I've got an angle there of, well, it's actually deflected 32 degrees. And if I activate that, there we go. So I'm looking for the quality of the, in this case, not the green surface mask, but the blue surface mask. So you can see it's there's lots of isolated islands there. And as I move my cursor around on the screen, you can see that angle of, well, what was, say, 25 degrees, 23 degrees. And as I move it around, it's jumping around. So it looks like there's undulations on the surface, or there's noise in the point cloud that's contributing to the variation in the angle that you're getting as you move your cursor around. So I thought this would be a good example where we can demonstrate to you how measurement plane in conjunction with surface angle is very useful. So here's where I press add measurement, go to measurement plane. And as you saw me do with the dilution chutes or the igniter ports earlier, I'm going to lay down 3 cursors on the deflected surface. Looking again, I've got good agreement now across that surface with my measurement plane. So there's my measurement plane, but if I activate my angle measurement, I didn't need to do that. There we go. So I basically now snapped my fourth cursor point to the measurement plane. So as I move that cursor around, oh, I need to move the cursor, not there. Okay. So actually what you can see, as I move the cursor around, it's basically glued to that measurement plane. And so that angle measurement now is not changing. So all of the noise and the undulations that you see in that small deflected area has been cleared by laying down those 3 points for the measurement plane. So as I move that cursor around, I can move it around in the point cloud. You can see it's continually sort of reading out the 31-degree value. So it's a good way of cancelling out a lot of the noise or the undulations in that in that surface that might exist, so that you get more confidence in the overall deflection angle that you have in that surface. Missing area, missing corner. So I've got some more angle recalled images to show you. So again, a lot of obviously missing material that you see on the corner of this compressor blade. Tap my measurement button, and you can see the new tile that we have here for missing corner. So just draw your attention to the top of the screen. When I press enter or I tap on the screen, measurement plane must be added before adding a missing corner. So basically, you're unable to generate a missing corner measurement until you've laid down a measurement plane. So go to measurement plane, as you've seen me do, lay down my 3 cursors. Forgive me for repeating myself, but it's always important to make sure that your 3D surface mask is in good agreement. So I'm checking the quality and the expansiveness of the 3D surface mask. So I've got good agreement, because now I'm going to be laying down a new measurement, add measurement, and I go down to, in this case, missing corner again, and I press missing corner. I'm now invited to add as many cursors as I like, provided it doesn't exceed 24. Don't forget there's a measurement plane on here, so I can be placing cursors that are, in thin air. So if I just press undo, go to roughly the corner of the blade, I don't have to lay down anymore, because as soon as I press done, it's going to snap the last cursor to the first cursor and give you this output. So I've kind of intentionally laid down those cursors very quickly without too much care, because this is the point where you can start adjusting and fine-tuning those cursors. So you've got the measurement that it is that you need the most accurate. Let me just minimize those buttons. First thing I tend to do is I'm looking at those projected lines that you see up onto the edge of the blade. So I just bring my mouse to it. So there's a line here between these 2 cursors, but it's also projecting up onto what is likely to be the leading edge of this blade. And likewise, from this cursor to this cursor, another projected line onto the tip of the blade. So I'm positioning this cursor so that these projections marry the original surface or the existing surface that you have on the blade. I'm conscious this is obviously not in the point cloud, so this is the 2D view. So I'm just going to do some rough adjustments. And just like you can, if you're doing area measurements or some other multi-cursor measurement, if you activate a cursor, let's just say activate that cursor and hold it down, a new one has appeared. It creates a new one between the one that you've just held down and the previous cursor. So you saw me apply cursors in a clockwise view. So when you hold the cursor down, it'll produce another one in the anti-clockwise view in this case. So that's just a quick tip of creating new cursors if you need to create new cursors. So I'm just roughly placing these down onto the edge of this surface. Checking my projected lines, it all looks good, but again, only looks good from a 2D view. So I'm going to go to my full screen point cloud view. You will expect it to obviously snap to the plane because we have a measurement plane. But here's a good point, a good instance where you can check with these guidelines that against the cursors that you're placing it onto the actual blade itself rather than in thin air. So those are in pretty good agreement. So you can only really do that by obviously checking the point cloud and maybe coming back to a view such as this and saving it and including it into your report. So there's your area measurement of approximately 47 millimeters squares. You've got 2 length measurements. Arguably, these are the most important that you require, is perhaps the length measurement for number 1. A lot of the manuals that acceptance limits for missing material are actually a function of caudal width missing material. So does it exceed 25% or 33% of the width of the blade? And you can only really determine that by doing this measurement and establishing the length of number one in this case. So that's about 10 millimeters. And you'll know in your manual what the full caudal width is for that compressor blade. And then from that, you can work out the percentage missing. But yes, we provide obviously the length of both lengths of that shape that's created plus the angle that you see. But yeah, just to recap, all those cursors up to 24 can be applied. Make really good use of the projected line feature that we have here, because if that is not appropriate, as I'm forcing it here, you can see that's having a massive effect on all of those measurements that you see. So make use of those projected lines and checking the point cloud. So I've taken you through angle, surface angle, and missing corner. Let's load up another image, press measurement, and quickly show you learn more. So you've heard me say we now have 12 measurement types on our MViQ Plus. The angle, surface angle, and missing corner are the new ones. If you wanted more information about these measurement types and other things on the Borescope, you can see this new button on the top right-hand side of the screen, I. So if I just press I, I'm now entering, as you can see on the status bar, I'm now in the Learn More state. And because I had depth profile activated, when I pressed I, we're now showing you more information about depth profile. And as you can see on the top right-hand side of this page, this is page 1 of 2. If I tap this button here, I'll be able to flick to page 2. So in all of these measurement types, we'll stick on this for the time being. So this is giving you more information and description about depth profile. Each page will also give you a typical voice command, sort of, hey mentor, add depth profile measurement. And it's activated. It's activated my system by saying that. And you see a brief video sequence showing you the process upon which, in this case, a depth profile is created. And in this case, if I went to page 2, there's supplementary information. So this is designed to help you get more information to make sure that you're applying the right measurement type to the right use case in your inspection task. Or indeed, it's designed to help you just learn more about what is possible on your Borescope. We're conscious that there's lots of different measurement types. We offer, obviously, a vast array. And sometimes, you've heard me say in previous webinars, when you're doing a length measurement, it might be more appropriate to use depth function, because depth can be described as being a sort of a point to surface, having more, if I press depth, there's more information about depth. So if there's more measurement types than we can fit on the screen. So you scroll down and you can learn more about all of those 12 measurement types. Plus, in this case, you've heard me talk about measurement plane. So there's a measurement plane isn't a measurement type; it's a measurement aid. But it's a really useful way to extract more use out of a lot of the measurement types that we have here. So lots more information there. So if I go back to my live screen and press the image button, this is what we call our image menu page. I call it the image transform page. So these are functions that allow you to alter the quality of the image that you're seeing in the live state. And so we call these image transforms. And as you've seen me say from a measurement page point of view, with the I for information at the top, there's one here as well. So if I perhaps go across to dark boost and press I now activate the learn more state in the image menu, and we're showing more information about dark boost. Just exactly the same layout or format that you've heard me describe it in the measurement state. So all of those image transforms, when you go into freeze frame and press image, there are other like zoom, for instance, those other image transforms appear. So I'll just demonstrate that. So if I tap the screen, go into freeze frame, go to page 2, press image, and you've got a different set of transforms here, for instance, in freeze frame and image. So you see zoom and split screen here, for instance. So these are the image transforms that correspond to this state in freeze frame. So all of the transforms associated with this state in freeze frame appear here in the freeze frame in Learn More. So that's the demonstration on those 3 measurement types and Learn More. Please do, if you've got any questions, please post them. I'm going to switch back to my presentation. Press a few buttons. Here we go. Brief moment talking about MViQ model designations. So MViQ plus model designations. So in the old Flame model, we had what do we have? It was inspect, touch, and analyze. Here we have start, enhance, and pro. So we still have 3 models, and the content of those 3 models is different and has changed. They're all touchscreen capable, unlike before with the basic inspect model of the outgoing MViQ model. Lots has changed, so please do. This is a very stripped down version. I didn't want to complicate the issue anymore by putting all of the content down, because we really just want to focus on the measurement types. But the ultimate, or the highest model tier, being the pro tier, includes all measurement bundles. If customers are interested in lower tier bundles, like the start and the enhance, we have these basic and enhanced measurement bundles that can be added to the start or the enhanced model. So we have a set of basic measurements, of which angle is included in the basic bundle. From an advanced measurement bundle perspective, all of the ones in basic are included in advanced, plus all of the others that you've heard me briefly talk about. That takes you up to the total of 12. And included in the advanced ones are missing corner and surface angle. So a few more minutes to go, just summarizing what I've taken you through. All of the new measurements, all essentially 3 new measurements, of which really surface angle is the true new measurement. We've lifted out angle and missing corner and dedicated new tiles to those. So we have 12 tiles now on the measurement page showing the different measurement types. And those measurement types apply to some of those bundles and not all of them, depending on which model that you have, that you've heard me talk you through. Spend a bit of time talking to you about Learn More. That's a new feature that we want to introduce to our users, to give them more bite-sized information, so they're not having to read manuals and go to websites and all the rest of it. Just brief content that's full of technical content and best practice, and even what the tips would be if you voice activated your handset to generate that measurement type. I always like to talk about the measurement handbook. It's a great resource. Of course, we've updated it to reflect all the new content that we have in the new MViQ Plus device. So please do, if you haven't already, go to our website, download it. It's all updated and all available to you on our website using that link. And to summarize, this is the second of several. I've got 6 lined up at the moment. So next week, we'll be talking to you about another feature that we've contained on our new Borescope. Our communication between ourselves and the Rheinstyle Future Drive turning tool has been improved. So we'll be spending some more time about that this time next week. And as you can see, there's more planned in the future. And again, if you haven't got questions, but you've even got perhaps suggestions about what else you'd like to learn about, then please do post those as well. Be really happy to kind of consider new topics to also include, so that we can add to the list and continue these webinars throughout the year. Let's take a moment. If there are any questions, then now's the time to read through them. If there aren't, I'll just dwell for a short period of time. If there aren't, then we'll close. But thank you from me. Went over 30 minutes again, like I always do. Thank you for joining. I will just pause briefly for any questions. Paul Thompson, what was the blue surface mask while placing angle cursors? So the blue surface mask, so unlike the green surface mask, which is plus or minus 1% of laying down a reference plane, the blue corresponds to a tighter tolerance between that fourth. So you were talking about the angle cursors. Let me just load up an angle. Let's go angle view. So for angle, there is no blue surface mask. You might be talking about the surface angle cursors, because the surface angle corresponds, and the blue mask corresponds to a very tight tolerance between the plane that was generated from the fourth cursor point, and that plane corresponding to the reference plane is what generates the angle you've heard me talk about. And that blue mask corresponds to the surface that in agreement with that plane. Alexa, thank you for asking for users with the previous name. Okay, yeah, I understand, Alexa, thank you. So everything you've heard me talk about with the MViQ Plus is unique to the MViQ Plus. So these 3 measurement types and learn more is not available to the outgoing MViQ model. When do you have the come up? I missed that question. If you could show it back up again. Oh, when do you? Okay, someone's asking, sorry, I don't catch your name, but an Apple MacBook remote review program. I don't actually know the answer to that question. Don't think we're working on that, but by all means, drop me a message, give me some more information about that, and I can respond in more detail, but I'm not aware of an Apple MacBook application that we're working on. Yeah, Paul's asking me another question about surface angle re-entry angle. I'm not familiar with re-entry angle, but if re-entry angle presents 2 different planes that obviously intersect each other, then yes, surface angle is ideal for that. Obviously, I took you through a blade tip curl application where there's a different angle, a deflected surface and a reference surface. If the weld's re-entry angle follows that logic, then yes, indeed, surface angle will apply. Great questions. Please keep them coming. Can I use point to line instead of missing corner? So if you had point to line with measurement plane, the answer is yes, to generate the length of one of those lines. You saw me do missing corner, and there was a length associated with line 1 and a length for line 2. If you did have measurement plane, if you had measurement plane applied, and well, depending on where you place your cursors, you might not need measurement plane. If you place them actually on the surface of the blade that wasn't obviously missing, and your third point along the tip, should we say, then yes, that would also generate a length measurement. Yes, that's a good point. Can I use point to line? Oh, sorry, I've answered that question about point to line. Certainly from the answer is yes from the point to line, provided you're just checking your point cloud, perhaps also including measurement plane as well, to make sure you're placing your cursors on the right surface and not on any deflected surface, then yes. Both of these measurement types are very helpful, thank you. And clients have been requesting, oh, I didn't read it. Nice product. Oh, thank you very much. Thank you, Paul. And thank you, LinkedIn user. Excellent. Thank you for your questions. If there's any more, I'll be happy to sit here and answer more of them. They're great. If there aren't, then thank you again for sitting through it. We've almost been an hour now, which is great. You can learn more. Yep, thank you for putting that banner up. There's lots of information on our website. You've got my name, you've got my contact details. If you need to reach out to me through LinkedIn or ask some simple questions through that. If there's more in-depth conversations, I can share my email address with you, and we can take you through more content. That's perfectly fine. Quite enjoy doing all of that. So if there's nothing else, I'll say goodbye and thank you. And if you can, join me next week where we'll learn more about what we're doing with Rhine style and turning tool communication. Okay.